Good afternoon, Ajahn. And today we are presenting our database finance project called Starchitex Hotel Management System. And this project follows a database a first approach where the database is responsible for the enforcing business logic, security, and data integrity instead of relying heavily on the application layer. And my teammates are the Alcanta, Milliken, and myself, Elvin. So let's begin with the agenda. Our presentation consists of five main parts. First, we will introduce overall system design schema and normalization. And next, we will demonstrate how we build an active database using triggers and constraints. And then we will explain how our system supports General Data Protection Regulation (GDPR) compliance. And after that, we will discuss multi-tenancy using the Progress SQL role-level security. And finally, we'll conclude our presentation with a live demonstration. So our project followed the FAT database in application philosophy. Instead of placing the business logic inside the Spring Boot, we move it into the PostgreSQL, and the application mainly send the requests and display results, while the database perform the calculation, validation, and security checks. So we also intentionally avoid using the Hibernate ORM, and instead we use the GDBC template with the raw SQL, so we could fully utilize the advanced PostgreSQL features such as triggers, store procedures, row-level securities, and constraints. So our database contained 26 tables organized into the state logic layers. And the first layer contained the independent reference tables like branch, gas, role, and run type. The second layer stores branch-specific entities such as rooms and employees. And the third layer is the reservation core. And the fourth layer handles daily all the operations, including runnability and maintenance, invoice, and survey requests. And the fifth layer manage billing through invoice items and payment. So finally, the sixth layer records the audit logs and reservation history for monitoring and traceability. So to maintain data in quality, our database follow that normal form. And first normal form ensure that every column store only atomic values. For example, instead of storing the multiple room numbers inside one reservation report, we use a separate reservation room table, and that normal form removes transitive dependency. So every non-key attribute depends only on the primary key. So this minimizes redundancy and improve consistency throughout the database. And since our hotel system support multiple branch, we design it as the multi-tenant database, and every branch has its own data and identified by the branch ID foreign key. And this design keeps all branches inside one centralized database while ensuring that each branch's information remains separated from others. So this also simplifies the administration and improve scalability. And we use several database feature to ensure data integrity, check constraint, validate data before it is stored, and before reservation takes must be valid. Uh, Also, for example, data our reservation dates must be valid, and we also prevent time travel errors by ensuring that checkout dates they always occur after the check-in dates. And finally, we use the enum types for reservation status and other predefined values, and this prevents invalid inputs and makes the data more consistent.
Where my session is about how Starchitex protects its own data integrity, and I will be clear through about what's running live right now versus what's designed and planned for the future. Uh, let's start with the classic hotel problem, the bed blocking. Our design uses a trigger on the reservation room link. So it checks for any overlapping reservation on the same room, on the same day, on the same time. So it it finds a conflict, it raises an exception, and the booking is rejected. So the key area is uh, that it lives in the database, not within the app. So no matter how the booking arrives, the rules stay the same. So this one is design and piece. We are finalizing our test suite. Already has the test written for it. Put it on the GitHub repo. So it's just waiting to pass the moment it deploys, and I will show it later. For the part about auto updating calendar, it is about keeping the room availability accurate. Rather than trusting the application for a user to remember to update the calendar, our designs uh, our design uses a trigger. So when a reservation is created, it writes the occupying across every night of the stay of a guest, and when it's removed, it releases those data back to the availability status. So the cleaner can never drill out things with actual logins. And we have a related trigger deploy and running today. And it releases rooms availability if its reservation link is ever clear. So the cleaner can never hold a ghost reservation or uh, a fake reservation without actually booking. For the part about the preventing overpayment and recalculation, this one protect against this fashion protect against the overpayment. So our design is aimed to record any payment which less the invoice rule, and it says what's already been paid by guest, and it computes the outstanding balance. If the new payment committed by a guest exceeds what's actually been, it's put into rejection state with a clear message like shown in the photo. For the slide about preventing overpayment, uh, it's like once the overpayment status is rejected, the invoice uh, shows an update, but the payment amount is remain the same. So we cannot physically pay more than a guest owns. So if a guest notice the leak and this function solved with the design that remains correct even if two payments arrive at the same time instantly. For the part about enforcing reservation states, it follow a strict life cycle: planning, confirm, check in, check out, with also a cancellation as an exit. So this diagram shows the only legal transitions. This design enforces with a trigger that a guest can skip from pending status to straight checkout, and guests can now receive cancel booking, which are on the terminal states. So any illegal transition is blocked with an error message naming exactly the reservation can only ever move through failed states. For the last slide of my part is about GDPR right to be forgotten. So the procedure means like a guest can request the deletion of the personal data after the SD is over, but also the SD legally needs its financial audit and record for next few moments. So our design resolves that tension with a procedure that anonymizes the guest, identifying information like NRC, passport, and birth date, and other personal information, while preserving the financial and audit records that must remain. So we satisfy the privacy request without breaking the laws and regulations.
Okay, so I'm gonna continue with a rule of security that we implemented in our database. So in what is rule of okay, what is rule of security, right? So let's say you're like without a rule of security, now everybody would have access to every branch or the ID. So I we separate by using like rule of security with I enforce is like using enable for the branch, right? So only um one branch, only the branch that, for example, if the employees belong to the branch, only can see the branch that related to it. So that is how I filter and like the rule of security, and I also force it to the 90 tables, like for branch and employee and so on. For like, for example, if you are a table create, if you are create out of the table, then you cannot even access to, you cannot have access to that table to like update the table or read the table because you it's mostly about like if you might have like the super user or the super admin to access those kind of like level, right? So okay, now we have a implementation. So if you can see here, we have like the super admin here. So if you are a super admin, you cannot access to almost like you cannot access to everything. So ensure that only the root admin can access to all of the table, like a CEO or the owners of the hotel. And also we also implemented here like to read the policy uh for the for example if you even though if you at this if you are even though like if a room guest like for the guest, right, it can only view or like read view the view it can only access it doesn't have like read write access, right? It can only like view the table view the info the data that available rooms and stuff, right? The payment information of their self, nor the other persons. So uh how do we implement this? So we have like here, right? So we will put like set at the current branch ID is equal to 1. So we're gonna have the every room ID and room number and branch ID will match to that is except like if you want to get a room, right, it should match to like at that starting branch, not the room for the other branch. So that's how we filter it from there. Like because we implemented it because in the normal in the real life, right, we have like the developer try maybe forget about to put like where clause. So the the Postgres SQL like reverse the query internally uses that policy to ensure that even though the developer messed up, is they have like the security filters applied to our applications. So as you see here, if a super admin is true, so we're gonna have every single run uh can be seen, right? So we then we also gonna have the proxy here. So what is the proxy? So like the for the backend we do use Spring Boot, right? So for the Spring Boot, it managed like for example, like if you try if the connection A is trying to connect right, so it's gonna have like a the object logs or like some kind of it's gonna have like the context when you connect to the connection, right? Sometimes it can make errors when you try to connect with the connection B and you still have the context of connection A. So we close that using like a using here like the Java, and we stmt.execute, like we have to reset every single branch before all the so to remove that context of the connection A, right? So and then so in this application we implemented like 10 rules and their permissions is 41 permissions and 42 permissions, and the rule is gonna be, so we have the several roles, right? We have like the administrator, the hotel owner, and the sales executive as a super admin, and the roles like some kind of roles are like the branch lock. So what it means is it can only access to the certain branch of itself. And we have guest who is like can only see the is current his like respondent variable, like view his own payment method or things like that. So we also feature the authorization separate from the data isolation. So we have like in the Java we have like the authorization using the Spring Boot, like well how which roles does it have, right? So, but our SQL ensure that even though if you get like authority, so which roles can you access only? So that is our implementation. And also for the analytics, right? I also implemented the materialized view, which is you can for the sale analysis, or like the owner, he might want to check like monthly review report instead of relying on like a reception and Dix interface. We kind of like do it in here, like in the SQL database, so it doesn't rely like mesh calculation. So this one is like so for this one, it's like kind of time free. So if you have to change it like if you want to get an update, so I trigger it using I used like a time reset every night, like around 2 a.m. To update the monthly report of it, so like the server doesn't crash after, or right. So for the conclusion, I want to say that this database, we implemented the database as an Azure engine, or like the Spring Boot doing all the stuff that for the application layer. So, and then we also ensure that the double blocking prevention and advice tech recalculation and the overpayment blocking, and so all using the triggers, constraints, and things like that. And then we also have like the Postgres root security, so only the like have a secure database access like to the certain people and to its role according to its role, right? So yeah. So and then we have the, as I said, we have like a PostgreSQL handling the data isolation and Spring Boot handling the authorization and authentication, right? So and then we have like normalized uh, we have a database, and overall for the future work, I think we will move like the permission table to the authorization, so you don't have to like recalculate from the database, which really help you have, this is really heavy, right? So and then we're gonna implement some soft delete, so it doesn't have to like to uh instead of like deleting the whole history, you just save the history of it, and then you just soft delete that portion, like let's say like putting it as a norm or something like that.
All right, let's continue with the remaining slides. I'm Milling Khan, and I'm going to present the remaining slides and demo pad. So, I'm talk about the login page. Now I'm going to walk through how each screen is powered by a specific data frame function. This is the head of our design, where every screen maps to a function that queries into a database. So if we are to start with login, it's like when a user enters their credentials and click sign in, the screen calls FN login. So it passes the username and password as a parameter. So the function looks at the store credential and it verifies the password against a secret hash and returns a simple integer, 0 for success and 1 for failure. So we can see the result on the shown in the slide. It returns 0, so the login cease. So the password is never compared in the application. The verification happens inside the database against the hash value. So one fashion, one clear result, driving the entire login screen. Let's move to another slide. So it's about room page. Once a user can log in successfully, the receptionist lands on the room page as we see in the slide. So the concept is that our key review of every room in related branch, the screen is powered by an available rooms function, which takes a branch ID, for example, in the slide, for Bangkok Riverside. So let's look at what the function returns. It returns each room with its number, floor, room type, base price, and housekeeping status. And you can notice it's already filtered intelligently. It only returns rooms that are clean or inspected, not currently occupied. So the screen shows exactly what bookable right now. The visual key we can see is a direct rendering of these rows, changing the branch in the drop down, and the same function runs with a different hotel ID, repopulating the whole screen. So the screen is all about the review and the function desk, the real work. Let's move to another slide. Uh, Next one is the reservation page. So the reservation page is served by FM branch reservation function. Again, scope by branch. So the result slide is that every reservation for that branch, which includes reservation ID, guest name, check-in, and check-out dates, the number of guests, and the current status. There are two things worth pointing out. First, notice that statuses cover the full life cycle. We can see pending, confirm, check-in, check-out, cancel, which I already discussed in previous slides. So this one function feeds the entire reservation management view. Second, this function is scoped by branch, which is our branch isolation side. So a receptionist in the Bangkok branch see only the reservation related to his Bangkok branch, so not the branch on the entire other city. So the green banner on the screen, reservation created status pending, is what a staff member sees after successful booking, and that new row would appear in exactly this functions output. So screen, action, and function are tied together. Let's move to the billing page. So the billing page uses FN guest folio function, which takes invoice ID and returns a complete folio. Here for guest, for as an example, as we can see in the slide, for the guest name Hannah Miller, this where the function does real financial work. So if you look at the columns, subtotal 5,250, test 367.50, and so that's the 7% of the discount and the total of 5,717. And critically, it computes amount paid and balanced due by semi-payments against the total. So this billing screen doesn't calculate anything itself. It just displays while the function returns and a match guarantee correct because of it derived in the database and protected by a checkout constraint. A single function call gives the front desk complete trustworthy financial picture of any guest stay so that he or she can inform the bill information clearly to the guest. So the last slide is about the revenue calculation. So this function only related to the manager role. So in the manager's revenue view, powered by the function called FM branch revenue, it returns the monthly revenue for a branch. Here we can see that is the Bangkok Riverside branch. The one the year meant June 2026. Two invoices. Revenue is 2051.50 July 2026. Two invoices 2689.50. So what makes this one special is that Hong is first. Revenue reporting normally means like scamming and sending every voice each time. So it's kind of expensive on busy system. Instead, this function reads from materialized view that pre-computes the totals, so the manager gets an instant answer, no matter how much it takes time to accumulate the data. So this directly addresses efficiency for heavy queries, which is like kind of important in the grading criteria. So we identify reporting as the heaviest repat and we optimize it with a pre-computer view. One function, instant branch revenue. So across all five slides that I've presented, login, rooms, reservations, billing, and revenue. Each one is driven by a dedicated database function, exactly as the design intents. Which brings me to where the project stands outstanding. So let's move on the demo pad. Here is the checklist generated by me. We put the comments for testing and demo. So let's start with connecting with the database. I'm gonna copy it and paste it on terminal so that we can access to the database from the external UI link. Right now, I'm gonna start the backend and front end. So let's run these comments. This is for the studying Spring Boot backend. And I'm gonna run here on the IntelliJ terminal. It takes some time to run. All right, it's running successfully now. Let's run the front end pad, which is I'm gonna run on the VS Code terminal where I open all the front end files. So the command is npm run def and sorry npm run def. Let's copy this localhost and we're gonna open it on the new page. For the demo pad, I make a three list to test, and here is the complete checklist. I put it in a Google Doc. So let's start with running the PSQL command on connecting the run database. I'm gonna run on the main terminal. Yeah, now it connects to the render database. All right. I'm gonna do the demo pad by logging with 3 different roles as an example. First one, I want to log in as the system administrator who have many request permissions to see the operations from different branches. So the username is admin here, admin.sys, and I'm gonna log in here, admin.sys. Yeah, it's successfully logged in right now. You can see there are so many branches for system administrator to check so that he can see all the related branches under our hotel management system. So here is currently on the branch of Bengal Riverside branch, and we can see available rooms, the reservation status, which is the pad of the front receptionist. The next one is creating the guest rule. Let's see. Let's try it with Isabel. Let's do as an Isabel. That's my name. It's just an Isabel. I'm gonna run Isabel data. As you can see, as I click the register guest button, it's successfully saved to our database. Here we can see this is the last data filled by me. This is the sample data. For the billing pad, currently right now there's no billing information because I haven't completed complementing the front pad for that billing function. So that's for all for the system administrator rule. So let's sign out and check with another rule. Another role is the front desk receptionist, and here's a username and port in a database. Let's log in with that. Session.pkk and password using pcrack hash. Let's see if we can log in successfully. Yeah, we can log in successfully. And this is also the same functions for the front receptionist. As a front receptionist, I'm gonna create a reservation for main camp, which is the guest I already created as myself. Check-in day gonna be maybe 17 July, and check-out day gonna be 30 July. I'm gonna create the reservation, and Yeah, we can see that the reservation is created. It's just the status pending. And as same with the system administrator, we can also register a new guest who is going to put into the new database. I already did it in the last but as a system administrator role, so I'm not going to do this here. And also the billing part, which I have completed implementing, so I'm going to skip this part here. So this is all about for the front-end research unit rule. And I want to sign out and try to log in with new different rule. And the last rule that I want to try out is the guest rule as a new guest. So this name is the demo guest. Password. I think I've imported this user information to the database. So the username and password land are not included in the database, so we can't log in. I'm sorry for this error. So let's test with the SQL query comments for each rule. First of all, let's see the text of system administrator, which is the reviewing of the audit tree. So I want to run this SQL command and I want to see the output of the terminal. As we can see, the result is like a table containing the ID, employee ID, guest ID, and other information about the reservation of a room. We can see the status of like whether it is pending or cancel, and if a firm receptionist changes to the cancel state, we can also see in this table. So it's about one of the tests of the system administrator. And another SQL command I'm going to run is comparing what each role can access to the database. This only can be seen by system administrator. And let's run this command so that we can see the name of the role with all types of permissions that assistant has given access to each role. As we are doing only with 3 assemble roles, we can only see the 3 roles and then the related permissions. As we can see, the permissions for the front desk position is the highest because he has to deal with a lot of requests per guest every day. This is about the checking the how many reservations are there by a front receptionist and lesson the SQL. And right now, the total of 22 reservations. And if we're gonna add a new reservation and it's gonna update if we run this secret again to 23. We don't have time, so I'm gonna skip this one. So another thing I'm gonna check by running the SQL command is the checking new booking, which is live in database. I'm gonna run this secret command, and we can see that the reservation made by me, we did it recently with my name Mincat. So we can see the status just stay pending with the accept reservation ID, which is 23. Because this is the last one I added to the database. Or so the previous reservation count is 22, but right now I added a new one, so it becomes 23. So that's all for the front receptionist. Uh, this one is for the guest rule. The guest can add manually about his information to the database, and let's see what happens if we run this command. So I guess successfully added his information on the database successfully, and those information can be seen by the front end receptionist and the system administrator role. Whether the I guess put the information on its or whether it's branch. So that's all about the demo pad for our project. And the conclusion I want to talk about is that currently right now we decided to do a real web app, so we have to deal with a lot of front end and back end things, API request and other endpoints, and we also have to check with the authentication layer. So we don't have enough time to finish implementing the whole database schema into the database. So all I've shown till now is the all about the Starchitex, where it's live, where it's in progress, and where it can be implemented next. Currently, what's fully working right now is that the database is live on Render. We already seen there are about 26 normalized tables, seeder and reachable. On top of it, the real authentication system with JWT and hash password. Those parts are quite challenging for us because we've never tried to implement the real world web app. So we take a lot of days to learn about how those JWT authentication and hash password work. So we fail many times implementing that. And another thing is an audit trigger that logs sensitive actions automatically and a few layer of check constraints and forcing the data integrity we have discussed in the previous slides. So I write 22 test cases and it all verify automatically in the live database and a working real console that the front end reads and writes it. So that's the core and that's real. So what's partially implemented is that our Ruby assessed control system is correct in database, like with the related rules and permissions are all there. But the enforcement layer that maps those permissions into real APIs isn't fully aware yet because it's quite challenging to deal with API. And as you also said that APIs are not main target of this project. So some employees are over restricted right now. That's why parts of the demo run through SQL rather than the app. And that's why I ran on the terminal. So we can know exactly where the bag is, where the wire fits, which one is not the side flow. For about this plan, we decide to implement before doing the report is that about server integrity triggers, uh, which is about debugging prevention, reservation state enforcement, overpayment protection, which are part of my presentation slides. Those keywords are written and reviewed, and they're just key for the deployment. We deliberately didn't claim them as live, and our own test suite flashed the debugging test, although it's not yet passing because we would rather have an honest test suite than a green one that lies. Yeah, that's why we are 100% honest about that. So what gonna grow from here is that we're gonna finish the RBAC enforcement wiring, so every screen walk end to end in the app. Another thing is applying the remaining integrated triggers and then those pending test screen. And we're gonna add the performance walk via scope, which is about more indexing and query optimization for the heavy reporting paths. For the long-term goal, the branch isolation model will be with all and me, means that this case cleaning from 3 operational branches to the full change on the GitHub. So the last thing is about the consistent principle behind it. That integrity lives in a database, not in application. So what Billy enforces that today what needs and extent is. So yeah, thank you for patiently listening my demo pad presentation. We would like to sorry that we're gonna arrive in time, so we didn't have the chance to meet with and show our demo in person to you. We are really sorry, Ajahn. And we're gonna do the remaining things next week before the report submission. That's all. Thank you.